Hey there, fellow coders. Welcome back to Toaster Code, the channel that turns plain text into tasty tech toasts. In today's episode, we are lifting the hood on JavaScript to see what's humming underneath. No scary buzzwords, just simple and clear explanations. We'll follow your code's journey step by step and discover why the browser sometimes feels faster than a Usain Bolt and other time lazier than a sleepy cat. So grab a snack, hit subscribe, and let's peek inside the engine of JavaScript together. Ready? Let's roll. So you are wondering what the hell this JavaScript is. Although we have already seen what JavaScript is in our previous video. If you haven't seen it, please go to our channel and do check out the first video of what is JavaScript. So like you might have seen your fellow developer friends who will keep on talking about the JavaScript like it's both their best friend and biggest nightmare at the same time. So what is this and why they sometimes say, oh, JavaScript is so good, and sometimes they're like, oh, I hate that shit. Why it is like that? So let's rewind the clock to 1995, where people were wearing baggy jeans, the internet were sounded like a fax machine or something, and the website looked really ugly. Okay, really ugly means it's really ugly. Imagine any ugly friend of yours, and JavaScript was more uglier than that. So at that time, there was a browser called Netscape Navigator. It was like the king of the internet back then, but it had one problem. Okay, it was dumb. It could only show stuff like you. Let's say we have a button here. Okay, that well, let's say you click on this button and something happens. Let's say a pop-up appeared. But back in 1995, when you click on this button, then you will not get to see any pop-up or any actions. You have to refresh the page. Once you'll refresh the page, then only you can see the pop-up. So that was the problem back then. At that time, this guy, this Brandon Ike, I don't know if I'm pronouncing his name correctly or not. If I'm not, then I'm sorry for that, sir. So he was the one who created JavaScript in just 10 days. Okay, this guy, he just said that, hey, hold my coffee. I'll build a language in 10 days that makes website interactive. And boom, JavaScript was born. Was it rushed? Yes. Was it ugly? Oh, yes. Did it work? Absolutely, yes. JavaScript let developers add things like pop up, they're annoying but powerful, form validations like you type your email correctly, clickable buttons that actually did something, and you don't have to refresh the page to see any changes after clicking any buttons. It was like going from a coloring book to a video game, the complete shift. Okay, so he was the one who created JavaScript just in 10 days, the Mr. Brandon Ike. Due to him, we are here today learning the JavaScript. Okay, now so JavaScript born, cool. But now let's talk about something that every JavaScript developers either complains about or pretends to understand on Stack Overflow, maybe. So that's JavaScript is single threaded. Now what is thread? No, it's not any thread from your shirt. JavaScript is single threaded. Basically, it's a fancy stuff of saying that it can only do one thing at a time. Imagine JavaScript as your tiny overworked intern. He has one desk and one to-do list. Okay, he can only do one thing at a time. No multitasking, no parallel processing. That's JavaScript. JavaScript single threaded means. So imagine JavaScript like your college crush. Okay, the one who only focused on you, not like your toxic ex who said goodnight to you, then stayed up chatting with your best friend, a gym trainer, and four other backup options. No, JavaScript is loyal. It finishes one job before moving to the next, like a disciplined monk, you can say. or that one crush who never replied but at least was exclusive to you. Okay, that's what being single threaded means. And everything in JavaScript, okay, every function, every operation, everything, it goes into a magical box. That magical box is called call stack. It's like a magic box of any magicians. Call stack is a way by which JavaScript engine keeps track of function calls in a program. If you think of a call stack like a stack of plate in the sink, something like this is a sink, and you're like just keep on popping a plate, one, then two, then three, and it goes on and on. So now if in this stack you have to do the dishes, you have to wash your plates, then what you will do, this was the plate which kept first, okay, and this was the plate which kept last in the stack. So on the first, it will the pop to pop out the plates, you will take out this first plate over here. Okay, this is the plate which you will take out from here for the first, and this will move out last. This is how basically JavaScript works, or the call stack in the JavaScript works. Okay, even if you like, you are familiar with the data structure and stack data structure in it, then this is how stack basically works in it. It's last in first out. That's what we call, you can also call it LIFO, last in first out. That's what happens in the stack as well. So it's like you add dirty dishes, you clean the top one first. Okay, you clean the top one first and you can't get to the bottom plate until you like pop up this one, then this, then you will reach to this last one. So like let's say you are cleaning this dish, till that time all these will have to wait there. Okay, it's not like you will directly, it's not like you will directly reach out to the last one and just leave everything waiting. No, this is not how JavaScript works. That's how the call stack is. And let's see the call stack with some code examples. So basically you can see here we have two functions, function one, okay, and we have the another function two. Okay, now what exactly it does, function one is just simple, it's just console log hi I am one, and in function two we are calling the function one and we are console logging hi I am two, and at the end we are just calling the function two. So now let's see how like the call stack will be created over here. Let's create a call stack. Okay, so basically just imagine this a call stack. Alright, now the first thing in this call stack will be global execution context. Global execution context will be the first thing that will pop inside this call stack. This is the first thing that gets pushed inside the call stack. After that, what will happen? Okay, so we are calling here the function 2 in the program. Okay, so now the function 2, this whole function, you see this whole function is going inside this here. This whole fun, it's not just that okay the function call or the console log, no, this whole function is going to sit inside this call stack, like the function 2, and we are calling here the function 1 and the console log. So this whole function is going to be here. So now if you will read here in this one, okay, in this one here we have in this function 2 we are calling function 1 as well. So now the next thing will pop inside this call stack will be the function 1. The function 1 will pop inside this call stack. Okay, now what this function 1 does, it just prints console log. that hi, I am 1. Okay, so now what will happen? Now we need the results. So how are we going to get the results? So now if you'll see here, what's at the top? At the top we have this function 1. Okay, we have function 1 at the top. So the first thing will pop out is function 1. So what function 1 is doing? Hi, I am 1. So the output will be, the first output will be this hi, I am 1. Okay, this is, we printed this. Now what will happen? This whole thing will be pop out. It will pop out from this call stack. Okay, now what's remaining inside the call stack? The function 2. What function 2 does? It calls 1. We already did this part. My bad. We already called and we printed it as output. Now what has happened? Console log 2. So it will print what's here in the console log. Hi, I am 2. So this is what will be the next output. Hi, I am 2. So behind this, just this simple code, this is what all the things happens. And after it will print here, this will also pop out from this. Okay, and after that this whole execution context, it will be gone. Its job is done. Now it's gone. When you will run a new program with new functions, new variables and everything, a new call stack will be created. Okay, so this is what all things happens behind the scene with the call stack. So that's why JavaScript sometimes feels that it's slow, but don't worry, JavaScript glow up is coming. How, like if you have seen any JavaScript program or you have written itself, then you might have seen that you don't feel anything like okay it's going slow or anything like that. It doesn't feels you. Okay, now why is that? It's all because of this magic, the V8 engine. Now what is this V8 engine? Okay, so let's see it. It's like it's something which makes this lazy intern to a Formula 1 car, race car. Okay, as we seen that JavaScript was single threaded, which is like a lazy intern who only does one job at a time. But how this lazy intern become the Formula 1 race car? It's all because of this V8 engine. It lives inside the Google Chrome. It's not inside JavaScript, not in your system anything. It lives in the Google Chrome. It's created by Google Chrome. V8 engine, it's basically the engine of, you can say, JavaScript. It's something that made JavaScript super fast. How it is and what it does, we'll see about it. Java's V8 engine is basically the brain that runs JavaScript inside your browser. Before V8 engine browser used to like interpret JavaScript line by line, like this is the code. So before V8 engine came into the picture, it used to first go through the line by line of every code. That's how it used to work. But now what V8 engine does, it's just the magic. Google is like okay, so it was like earlier it was like reading a recipe aloud as you are cooking, slow, painful, and sometimes you burn your pasta as well. But then Google said enough is enough. Then they built V8 engine, which doesn't just read your JavaScript, it compiles your JavaScript code into the machine code. Now what is machine code? It's something that computer understands. Understand by computers. You are writing this function. Okay, this function, Java, your computer doesn't understand this plain English things. Okay, so your code, it gets converted into machine code, then only it computer can understand that what you want exactly from me. Okay, so um, it's like machine code is something like your computer understands, and that means speed. Like when computer got it that okay, what I have to do, it can do that in fraction of seconds. Okay, v8 is just in time compiler. We also call it JIT, just in time compiler. Okay, it means it watches your code, sees what runs a lot, and goes like, ah, this loop again, let me optimize this for you. It's like a gym trainer who notices you like you keep skipping your leg day, so he built a shortcut just for the squats. Boom, faster, smoother, swall. So now you don't have to run. So this like because of this V8 engine, okay, Java people started taking JavaScript seriously. Before that, it was like okay, JavaScript is a clown. I don't want to use that. I don't want to read that. But because of this V8 engine, people started taking JavaScript seriously. After V8 engine, apps become snappy, browsers could run games, people stopped bullying JavaScript, and JavaScript jumped from earlier JavaScript was just like a front end helper, but now it's a full blown backend language thanks to Node.js also. If you don't know Node.js, don't worry, we'll see about it later on. So now what V8 engine exactly does? Okay, that's a cool thing we are going to see. So let's say you have written a JavaScript code. Imagine as this is the code you have written. Okay, this code over here. So you written this code. Now you run the code. So it goes to your Chrome V8 engine. Okay. Now what V8 engine does to your code? First it parses the code to the engine. Then it goes into this abstract syntax tree. Okay, abstract syntax tree, like after the here the ignition happens and it converts it into bytecode. Okay, then the turbofan converts this bytecode into the machine code. Okay, and then this machine code is something that computer can understand. Then your code runs on the CPU. Got it? This is what all happens behind the scenes, which you don't even like. You don't even know. You just run the code, and nothing of these things you can see. It just happens there. It is there. So, I would let's say you are running any code, okay, and you might never see in this delay in the code. Okay, so you just it was like you said that JavaScript is single threaded, it can only do one task at a time. Okay, and now you are saying that it's also fast. So how is it? It's all because of JavaScript is single threaded, but it had got helpers. Okay, other thing, so before those helpers, let's see about event loop. What event loop? It just keep on checking. It's like as the word itself suggests, the loop, it keeps on checking the call stack. Okay, that if the call stack is empty or not, is there anything that is waiting inside the call stack or not, okay, to run or to execute it later. So it just keep on checking the event loop. That's what it's also make it fast. This whole process, like it makes this asynchronous code work in the single threaded in JavaScript. Okay, so that's why it feels fast, because nothing is waiting. It's not like okay, you finished one task from the call stack and then JavaScript just went into waiting period. No, it doesn't, because this event loop, imagine this event loop as the manager. He just keep on checking the schedule of this call stack, and like scheduling the meeting to the next person, or asking the next person, hey, my boss is free, come see him. Okay, that's what the job of the event loop is. It's not multitasking, it's just the delegation of the tasks. Okay, now why the JavaScript feel fast? It's because it has got helpers. Okay, so like you remembered like JavaScript is like your loyal crush, single threaded, and does only one thing at a time, no cheating, no side tasks, nothing. But then how it does stuff like waiting for 2 seconds and then printing something, responding when we click a button, or loading data from a server, like so here is the secret. JavaScript is single threaded, but it has helpers inside the browser. Okay, where are the helpers? Inside browser, and we call it web API. Okay, think of it something like um, JavaScript is you, okay, and like browser is your mom, okay, and then the web API is like helping aunts, helping aunties of your mom. Okay, so imagine this case. JavaScript is you, browser is your mom, and web API is helping aunties of your mom. Okay, so now let's say you just you walked into the kitchen and you asked your mom that hey mom, I'm hungry, can you make me a noodle? Then your mom is like, okay son, just wait for 2 minutes, okay, I'll get you the I'll get you the noodles, okay. And your mom set a timer of 2 minutes, okay. Your mom just set the timer of 2 minutes. Then you don't just stand there, okay, that wait for the 2 minutes to get the noodles done. You went back to your room, you are watching cartoon or play games or talking to your girlfriend, whatnot, or boyfriend, whatever. So after 2 minutes your mom walked in and said, hey, your noodles is ready. Okay, now how it happened? You just got your noodles and you started eating, but you don't know the process behind that. Your mom is also not free. She is busy like working on her, let's say she is a working mother, she is doing attending a meeting or anything like that. So how this all happened? So for waiting for 2 minutes, sorry, for waiting for 2 minutes, we need in the JavaScript a thing called set timeout. Now JavaScript don't have any timer or anything that it will wait for 2 minutes. Okay, JavaScript can't wait. It just keep on running and running and running. So how it all happened? It's like um your mom, okay, she was just busy working on something, and then she's like she put your noodles on the stove to working, and then she asked the helping aunties of your mom, she asked that hey, after 2 minutes just remind me that the noodle is ready, okay. And after 2 minutes these aunties just reminded your mom that hey, the noodle is, you asked me to watch out your noodle for 2 minutes, is it's done, and your mom gave you your noodles. Imagine let's see it like here in this, from this code, okay. We have the console log high, then we have set timeout, uh, this is for 2 seconds, okay. Here we are printing later, and then console log by. So how it will happen? First JavaScript will read that console log high, JavaScript will print high, then JavaScript will read set timeout, then it will directly reach out to browser, okay. It will reach out to browser and say browser that hey browser, can you remind me after 2 seconds that I have to do the run this console log part? And browser is like, okay, no problem bro, I got you, okay. Then JavaScript doesn't wait, okay. It done this, it asked this to wait to browser, then it moved to this line, and it will print here this, bye. After that, the browser went back to JavaScript. Okay, it went back to JavaScript and said, hey, your 2 second is done. Okay, then JavaScript go back and it will print later. This is how JavaScript works. This is how its functions works. Okay, this whole teamwork is what makes JavaScript feels like it's doing many things at once, but really it's just delegating the tasks, nothing else. They are just delegating the tasks. Okay, so it's just how we are going to conclude it. We can say that JavaScript is not multitasking. Okay, JavaScript is not multitasking. It's just really good at saying that, hey, can you handle this task for me and tell me when you are done. Simple, smart, no stress. That's what JavaScript is. Okay, so now let's see what we have read till now. Okay, what we have understood till now. So first thing is JS is single threaded. JavaScript is single threaded. Then we saw the call stack. Okay, then we saw the event loop. Okay, then we after that the V8, we saw the V8 engine and the web API. The V8 engine and the web API. Okay, this is what we have seen till now. So even though JavaScript is single threaded, he looks smart because he has a full squad of helping him. Who are the squad? These are the squad. This browser is your mom and the web API. They are the JavaScript squad who are helping it to run it faster. That's why JavaScript never freezes unless you make it like you just wrote a while loop which just keeps on running forever. Then it will freeze, obviously. Otherwise, JavaScript never freezes. It's busy delegating tasks, staying cool, and running smooth. So next time someone says that, hey, JavaScript is single threaded and it can't multitask, just tell them, bro, it doesn't need to. It got this helping aunties. Okay, and that's the tour for the day. Okay, that's the tour for in this video. Let's revise one more time about the concepts. JavaScript is the brain. Okay, we'll let's just see here. JS is the brain. Okay, then browser is the muscle. That's the muscle. Okay, it gives JavaScript superpower. Web API, they are the helpers, like the help handle like waiting tasks. Okay, then call stack is the to-do list. Okay, then the callback the event loop will be the manager. This is what makes JavaScript amazing. Okay, this is how JavaScript really works behind the scenes. Okay, and so the next time when you write console log hello, remember that there is a whole team of hustlers working behind the scenes. Okay, this all together. Okay, this all together, they run the entire JavaScript circus with zero overtime pay. So if this video made JavaScript even 1% clearer to you, Smash that like button like it's a stubborn bug. Hit subscribe for more crispy coding content, and I'll see you in the next one. Until then, keep your code crispy and your coffee strong.